Hey class, thanks again for your understanding about, not having class and have this video here. What we are going to do is what we talked about in class on Monday, which is I'm going to go through the even problems here for this section. We're going to be solving exponential equations. So this is different. What we were doing in class on Monday was we were solving log equations, and we kind of got a feel for how to go about those. There were different methods we used. Depending on what we were presented with. With these exponential equations, we're going to have the same sort of thing. It's like what we do kind of depends on what we have. So we need to kind of get a feel for the different flavors here. So let's start off with our first problem here. We're going to take number 46, and we're going to be trying to solve for x, right? So solving for x here, first thing that I'm going to point out is, where's the x, right? So the x here is up in the exponent, right? If the x were inside of a log, we do what we did, in the previous class on Monday. Here, because the x is in the exponent, we want to somehow get that x down, get it out of the exponent. And the way we do that is to convert this to a logarithm. So instead of using the loop like we did for the previous problems, we're gonna do the reverse. We're gonna create a logarithm out of this expression. So this was kind of the tricky thing that we did 2 class periods ago. Converting this to a log, we have to write log down, and then we look here at the base. So that's the base of our log, and then I like to put the equals, and then I just like to think about what the loop would be. So 5 would be needed. We need to raise 5 to some power to be equal to something here. So in the problem, we have 5 being raised to the negative x, which makes me put negative x here. And then that must be equal to the 25, the other side of the equation. So I hope that's clear that when you do the loop on this, you would get back this right here. So, okay, that's it. Now let's figure out the left side of the equation. Well, the left side of the equation, we can use the property from class here, this very, very important change base formula. Okay, we talked about this. It says if we have log of any base of anything, we can use this to figure out the log. So we only need one key on our calculator. So this becomes, this right here turns into natural log of 25 over natural log of 5 equals negative x. So I'm going to get on my calculator. I'm going to do that. Natural log of 25 divided by natural log again of 5, and I get 2 equals negative x. And then now I want x, so let's just multiply both sides by negative 1. And we get a solution here. Now, I should point out, you could have gotten this answer without a calculator because we kind of know what this is saying, right? Log base 5 of 25 really means 5 to what power is 25? So we say, oh, well, 5 squared. So the answer, we could have gone directly to here and then just, do the negative on both sides. I believe most of the problems here are going to work this way because this is the way that they're designed, but we can use our calculators as well. All right, so let's look at our next problem here. 48. Pretty much same thing here, nothing crazy. We've got something raised to the x equals 14. So right away, I can take this to a log. Okay, I can go log base 3 equals, well, what am I raising the 3 to? X, right? So I'll put x over here, and then the other side of the equation is 14. There we go. Yeah, you know what? We're going to need our calculator here, actually, because we can't figure this out in our heads. 3 raised to what power is 14? Don't know, right? So I'm just going to get on my calculator. Natural log 14 over natural log 3 equals x. Let me go ahead and do that. Natural log 14 divided by natural log 3. And I get approximately 2.402 is equal to x. And I'm done. All right, smooth sailing so far. Let's go with number 50. And I think we're pretty much gonna have the same sort of thing going on here. Nothing crazy. All right, so here we're gonna make our log. Our base is gonna be 2. Other side's going to be negative x, and then here we're going to have 1.5. Again, I don't know what I raised to. I don't know what power I raised 2 to in order to get 1.5. So I'm going to do my change base formula. Natural log 1.5 for natural log 2. This should be equal to negative x, and I'm getting used to this on my calculator now. So natural log 1.5 divided by natural log 2, and I'm getting about 0.58. We'll go 3 decimal places. Is negative x, and now I multiply both sides by -1, and we have solved for x. So this is really nothing crazy here. I mean, all we're doing is turning it into a log, change of base formula. We're in business. You're waiting for the foot to drop here. Okay, well, here we go. We got something a little different here. So difference on this one is we've got something to a power, right? We've got this thing 4 being raised to this power, just like we had the 2 to a power, and up here we had the 3 to a power, and here we had the 5 to a power. Here we got a 4 to a power. It's got the x in there, but we've got this 0.3 out here in front. We cannot convert to a log unless it's just something to a power by itself. Then you can go to the log. So I need to get rid of this 0.3. It's being multiplied here. So I'm just going to do one preliminary step. I'm going to divide both sides by 0.3. Okay, so when I do that, it goes away here. I get 4 raised to the 0.2x equals, and then I just get on my calculator, do 0.2 divided by 0.3. I get 0.666 forever. Okay. All right. Well, it is what it is. Let's just keep cranking away here. We can now do the log. So we can do log, the base is 4. The other side should be 0.2x, and then this should be our 0.666 repeated. Now we will have to round here. So I'm going to go to the change of base formula now. This side should be natural log of 0.666. I'll just do 3 6s over natural log of 4. Don't freak out. 3 6s. It's okay. The world will not end. Okay, here we go. So I'm going to go natural log 0.666 divided by natural log of 4. So the left side becomes negative 0.293 equals 0.2x. One last step. Divide both sides by 0.2, and we get approximately negative 1.46. Oops, 1.466 equals x. There we go. We've got our solution. Now, if you notice, I haven't been checking my answers, and that's because exponential functions don't have domain restrictions. You can plug anything you want into an exponential. You don't have to worry about, like we did with the logs, you couldn't plug negatives in, so we always had to check our answers. Here, exponentials are fine, so our answers should be fine. Now, there may become a point here later where we have to, but let's just keep going. You'll see what I mean when we get to it. All right, that was number 54. Okay, finally something different. Okay, here we go. Now things start to get interesting. All right, so here, the thing that we need to notice is that the x we're trying to solve for is actually in the exponent on both sides of the equation, right? It's on both sides. So we got to get the x down. The problem is you can't go to a loop right away because well, on all these, we have the loop, and we actually, when we do the loop, the other side of the equation, right, is just a number, right? We have something to the x power, and then we've got a number over here. So when we do this part, everything works out great. Okay, so there's multiple ways to do this. I'm going to show you the way that I think is the cleanest way. Probably, you could debate this, okay? But here's what I like to do. What I like to do is, because these are different bases, right, 2 and 5, what I'm going to do is I'm going to take the natural log on both sides of the equation. All right, now I know this is our first problem where you're like, what in the world are you doing? Okay, now here's the reason I'm doing this. There's a property of all logs that we talked about where we said that if you have log of any base of anything to the n power, the power can come out, right? And if it's a natural log, then the power can come out also, right? So what I'm going to do here is I'm going to use that property that I have basically natural log of something to a power, right? And then over here I have natural log of something to a power. So the property is that I can pull those powers out. So I can take that x plus 1, I can drop the whole thing in front. But because it's 2 terms, I need it in parentheses. So I'm going to put x plus 1 natural log of 2, and that's multiplication. Then on the other side, I can pull the 1 minus 2x out front, and then times natural log 5. All right, so we pulled these things out. And now at this point, the x's are now down, right? They're down. We've got some natural logs in here. It's a little weird, but we should be able to go with this. So now what I'm going to do is, and again, there's different ways you can do this. I'm going to distribute this natural log of 2 through. Now think about this. Natural log of 2 is just a number. I can do it on my calculator right now. It's 0.693 something. I'm just going to leave it as natural log of 2 and just distribute it like a number. So I have x times natural log of 2 plus, let's see, natural log of 2 times 1 is natural log of 2 equals, now I distribute this through here. I get natural log of 5 minus 2 times natural log of 5 times x. So all I did there was I multiplied the 2, the x, and the natural log of 5 together. I put the two numbers here together in front of the x. I guess on the other side, I could have put the natural log of 2 in front of the x, but it's okay. At this point, I'm going to move everything that has x to the left side, everything that doesn't have x to the right. So I'm going to add 2 natural log 5x over here, and I have to add it over here. And then I'm going to subtract natural log 2 here and subtract natural log 2 here. So that goes away, that goes away. What I'm doing is basically solving a linear equation now. I'm going to write natural log of 2x equals natural log 5 minus natural log 2. I know this is weird. Okay, I know it's weird, but just hang in there. Normally, this is where I'd ask if y'all have any questions. I hope you don't. I've distributed this number, some decimal, through here, and I've distributed this number, natural log 5, through here. I've moved all my x's to one side, everything that wasn't x to the other side. And now the reason I did that is because here, what I can do is I can, on the left-hand side, I can factor an x out. So if I factor an x out, I'm left with 2 natural log 5, and then I'm left with plus natural log 2 equals the right side, natural log 5 minus natural log 2. And we're almost there. I've almost solved for x. I just have to get everything in parentheses out of here. So I'm going to divide by 2 natural log 5 plus natural log 2, and then do the same thing over here. 2 natural log 5 plus natural log 2, divided on both sides, it goes away. And you finally have an expression for x. X is equal to natural log 5 minus natural log 2 over 2 natural log 5 plus natural log 2. That is our exact answer. If we wanted to, we could get on our calculator and figure out what this is. I'll go ahead and do it so you can see it. But that to me would be a perfectly fine answer. Natural log 5 minus natural log 2. So just so you can see this, the numerator comes out to be 0.9163 over, if I do 2 times natural log 5 plus natural log 2, the bottom becomes 3.912. And then I can divide those. And I get approximately x is equal to 0.234. There we go. That is our solution. Very, very weird problem because, again, you had this weird thing where you're working with this natural log 2, natural log 5, right? And then just get used to it because that's kind of like the nature of the beast at this point. Let me see. I kind of want to see maybe if there's a different way you could approach this problem. I mean, you could. There's so many different ways to go about this. That's the way I like to do it, but I'll show you a different way. We could do the loop. Okay, watch it. We could do the loop here. Let's see. The loop actually might not be that bad. Let's look at this side with the base 2 and do the loop. I would write log base 2 and then equals. Okay, so what am I raising my 2 to? Well, x plus 1. So I put x plus 1 over here. What does that have to be equal to? Well, it has to be equal to 5 raised to the 1 minus 2x. All right, that's weird. That's weird. All right. So I did my little loop here. I hope you agree that 2 raised to the x plus 1, that's the left side, must equal 5 raised to the 1 minus 2x. So that matches up with this equation. Now, what's kind of cool about this is now you can use that same property that you have log of something to a power. You can pull that power in front of the log, and you get 1 minus 2x times log base 2 of 5, because you pulled the power out, equals x plus 1. And log base 2 of 5, you can actually figure that out on a calculator, because we know that this is natural log of 5 over natural log of 2. So we could get that as a decimal. If I do that, I get, let me see, natural log 5 divided by natural log 2 as a decimal. This becomes, let's see, 1 minus 2x. That decimal is 2.322, and then equals x plus 1. And now you can just distribute the 2.32 through. So you get 2.322 minus, let's see, if you multiply 2.322 times negative 2x, you should get negative 4.644 x equals x plus 1. And now get all your x's on one side. So I'll add 4.644x to both sides. And I'll take 1 away from both sides. So I get 1.322 equals, when we add this 1x to this, we should get 5.644x. And now I'll divide both sides by 5.644. So 1.322 divided by 5.644, and I get approximately 0.234 equals x. Same answer. Okay. So just a different way to do the problem. And I don't know, I'm kind of like, you know, I don't care which way you do it. Just go with what makes most sense to you. Yeah, let's do another one. And we'll start to get a feel for this. So that was 54. Let's look at 56. 56 has some fractions in it. Oh, I thought I just had a panic. I thought maybe I forgot to record, but I'm going to pause real quick, get a drink. Okay, this one's very much like the last one, because we have two sides of the equation that they're both raised to something that has an x in it, right? So I don't know which way you preferred. What should I do? I'm doing natural log, okay? I'm going to do this one. Do natural log on both sides of the equation. So natural log of 4/3 raised to the 1 minus x equals natural log of 5 to the x. Now I will drop this power out. I will drop this power out. So 1 minus x is 2 terms, so I need it in parentheses. Natural log of 4/3 equals x times natural log 5. Now, I'm going to go ahead and turn those into decimals, and I forgot my calculator. I'll be right back. All right, the natural log of 4/3. So I get 1 minus x times 0.287 equals, and now I'm doing natural log of 5. I get 1.609 in front of the x. Then I'll distribute this through. So I get 0.287 minus 0.287x equals 1.609x. And we're getting there now. We can just get x on one side, so I'll add this to both sides. All right, so 1.609 plus the 0.287 is approximately 1.896. X equals the other side, which is 0.287. I'll divide both sides now. 0.287 divided by the 1.896, and I get 0.1514-ish is x. All right, there we go. All right, 58, pretty much same thing. But I'll be thorough. I'll go through all these. So let's go with that natural log. Natural log of the left side equals natural log of the right side. Drop the powers. Make sure they're in parentheses. And get on your calculator, do natural log 0.3. So you get a negative number here. You get times, since it's a negative, I'm going to put it in parentheses because it's multiplication here, negative 1.204. And then over here, 2x minus 1 times natural log of 1.7 should be times 0.531. All right, let's distribute these numbers through. So I should get negative 1.204 minus 1.204x equals over here, distribute this here and here. So when I do the 0.531 times the 2x, I should get 1.062x. And when I distribute it to the negative 1, I get negative 0.531. All right, let's get all the x's on one side. So I'll go ahead and add 1.204x. 204x to both sides. It'll go away here, and I will add 0.531 here and add 0.531 there. They go away here. So let's see, this should be 2.266x. And when I add over here, I should get 537. Oh, wait, oops, I'm subtracting. I'll just do it here. Negative 1.204 plus 0.531, negative 0.673. And then divide that by both sides by 2.266. So we should get negative 0.29, I'll round to 7 is x. Okay, I think we get the point here. I hope you do. It's kind of messy with these decimals, but it's the way it is. All right, let's do something new. No, it's not new, but it is actually a decent problem because it's got some weird numbers in here. So for this, I'm going to do natural log on both sides again. So I'm going to do natural log of the left equals natural log of the right. That's pi to the x. Now, the left side, the x plus 3 comes down. Okay, this x plus 3 comes down. I have x plus 3, natural log of e, that's weird, equals over here, x comes down, and then natural log of pi. Now, I'll remind you, natural log of e, if you do it on your calculator, you can get an answer, but we also talked about some of these properties. And, well, you know what? I didn't do it here. I did it in the, oh, here it is, natural log of e. Natural log of e is 1, something you should know. All right, that's one of these things that you'll see again in calculus. So natural log of e is 1. So this side just becomes x plus 3, and then over here I have x times natural log of pi. So you're going to have to use your pi key, which is actually below your natural log key. Hit natural log pi, you should get something like 1.1447x. And then I'm going to subtract x on both sides. So take 1x away from that. So we get 3 equals, I'm taking 1 away, I get 0.1447. And I'll divide both sides by 0.1447. So I should get an answer here for x. X is about 20.733, something like that. Okay. 62. All right, finally something different. Okay, so number 62. This is a good problem right here. Okay, so for this problem, notice that this is the first time that we've seen, x in two different expressions up in the exponent here and here, but we also have this new additional term that does not have an x in it. So we actually have three terms. So what you need to see here is that if you rewrite this, okay, so remember this property of exponents. You have x, raise it to the n to the m. That's the same as x to the n times m. So multiplication of two numbers is the same as something to a power to a power. So what I'm going to do is I'm going to rewrite this first term here as 3 to the x squared. Now, the reason why that's this is because if I were to take 3, raise it to the x, raise it to the 2, I need to multiply these two together, and 2 times x is 2x. So this is just a very kind of clever way of rewriting this. And the reason I did that is because I have another one of those right here. And I put in parentheses for a reason, you'll see in a second. It's just to stress now that what's in yellow here, I'm going to make a substitution. I'm going to make a substitution. I'm going to let u be equal to 3 to the x. And if I do that, then this whole thing becomes, well, that becomes u, but then squared, then plus this right here, that whole thing is just u, and then minus 2 equals 0. And now we have a quadratic. And since I have a quadratic, I can factor or use quadratic formula, but this factors u plus 2u minus 1 equals 0. And then we get two answers. U must be -2 or u must be 1. And now what I'm going to do is I'm going to replace u with what it was. So u is 3 to the x. So this is 3 to the x must be -2. And this is 3 to the x must be 1. Now we're finally back to what we were doing in the very beginning of this section of homework, which is these very basic problems, right? So what I'm going to do is try to rewrite this as a log. I'm going to go log base 3 equals here. And then I'm going to do the loop here. So 3 to the x must equal -2. Now on this one, the same thing. Log the base is 3 equals here, x on this side and 1. All right, so what do we do? Well, if you try right now, if you try to do this using that change of base formula where you convert that into natural log -2 over natural log 3, or on this one you do natural log 1 over natural log 3, that one will work. But if you type this into your calculator, natural log of -2, you should get an error. In fact, mine says domain error. And that's because we have to remember that you can't plug negatives into natural logs. So it's impossible for this equation to ever be true, which means there's no solution for this part. Okay, now over here, if we do natural log of 1 over natural log of 3 on our calculator, we should get 0. So our only solution to this equation is 0. All right, so we had to look at this. We had to see that it looked like a quadratic by making this change here and then doing a substitution. Once we do the substitution, we solve, switch it back to what it was, and then solve those little equations using logs. All right, let's do another one of those. This one's tricky. Okay, so look at this one for a moment. Give me just a second, let you look at that. Okay, so on this one, we have something that looks very similar to what we had just a moment ago. We have something where this could be rewritten as 2 to the x to the second power. And then that would make us think, all right, well, let's make the substitution u equals 2 to the x. The problem is the middle term here is not just 2 to the x, it's 2 to the x plus 2. So I'm going to use another property that if we write 2 to the x plus 2, that is the same as 2 to the x times 2 to the 2. And that's because there's a property of exponents that says if you have x to the m times x to the n, you add the two exponents. So what I'm doing is I'm using that property, but backwards. I have something to two things being added, so I can rewrite that as the something to the first power times the something to the other power. Now, the advantage of doing this and seeing this is that this number is just 4. So I could put that in front of the 2 to the x, and now it looks like this. So if I write this as plus 4 times 2 to the x, that's the same expression. And now we can see that we can replace that 2 to the x with u. And now it becomes u squared plus 4u minus 12 equals 0. Now, be careful here. Students will make this mistake. They'll do, oh, 4 times 2, that's 8. Can't do that. Order of operations says you must do exponents before the multiplication. So you can never combine those two together. So you leave it, right? Don't do that. So we're down here at this quadratic. Let's see. Does it factor? It should factor. Plus 6 minus 2. And then we get 2 answers. U is negative 6. And u is 2. And now I switch back. What was u? Well, u is 2 to the x. So 2 to the x is negative 6. And 2 to the x is 2. And now I'm going to rewrite those using the log. So this is log base 2. This is x. Do the loop. Negative 6 there. Oh, this is no solution. I can't do that. I can't plug a negative into that log. So there's no solution here. But on this one, when I do my log, I'm going to say, well, wait, hold on. I don't need the log because I know what this power is. Look, it's 2 to the x must equal 2 to the 1. So the x must be 1. So you get x is 1. Now you could do it. Okay, if you did want to do this, you could do log base 2, make this side x and make this side 2, and then do that on your calculator. That would be natural log 2 over natural log 2. And of course, that's 1. So you get the same answer. All right. Next one. Where am I? That was 64, 66. All right. Another slight variation of the problem we just did. So on this one, notice we have that same thing here. That 3, I know I can rewrite this as 3 to the x times 3 to the 1, which is the same as 3 times 3 to the x. I still have plus 1 equals 0. Now that makes us think we're going to make a substitution. U is 3 to the x. But this is 9 to the x. So what we need to realize is that 9 to the x can be rewritten as 3 squared, that's 9, to the x, right? That's the same thing. And that's the same as 3 to the 2x, right? You multiply the powers, and I could even split that up and make it go back to this, 3 to the x times 2. I know that's weird. We're rewriting the 9 because this u, I want to make a substitution of 3 to the x. So I'm trying to rewrite this as you know, something to the x. So I have to first rewrite the 9 as 3 squared. Then I use the property that I multiply these two to get 2x. And then because multiplication is commutative, you could have rewritten that as 3 to the, instead of 2 times x, the x times 2, and then convert that back over to this. So that is what I can put out here in the beginning, 3 to the x squared, and then this was a minus there. That's tricky. That's tricky, but it works. This is my u, right? So this becomes u squared minus 3u plus 1 equals 0. All right, that does not factor. This does not factor. So I have to use a quadratic formula. So my solutions are u is negative b plus or minus the square root b squared minus 4ac, all divided by 2 times a. So for us here, a is 1, b is negative 3, and c is 1. So we should get 3 plus or minus the square root of b is negative 3, right? So we're squaring it, we get 9 minus 4 times a, which is 1, times c, which is 1, all over 2 times a is 1. So we get our solutions are u is 3 plus or minus, let's see, that's 9 minus 4 in there. So 3 plus or minus root 5 over 2. And I'm going to go ahead and get those as decimals. So I'm going to go 3 plus the square root of 5 So I'm doing 3 plus the square root of 5, and then I'm dividing that answer by 2. So one answer I get here is 2.618. Then I'm going to go 3 minus the square root of 5. Oh, wait a minute. Yeah, divided by 2. Okay, so now I do 3 minus the square root of 5. Take that, divide by 2. And we should get another answer here of 0.382. Okay, and then now that's what U is, right? Those are 2 solutions for U. So U has to be 2.618, or U has to be 0.382. And then remember what U was. U was 3 to the x. So that means 3 to the x has to be 2.618. And 3 to the x has to be equal to 0.382. And now I'm going to create my log base 3, 2.618 equals x. The other one is log base 3, 0.382 equals x. And then I'm going to use my change of base formula. And so this is natural log of 2.618. Or natural log 3 equals x, natural log of 0.382, or natural log of 3. So we're going to get our 2 answers here. I'm doing them on my calculator. Divided by natural log of 3. So this becomes 0.876 is x. And then this one, natural log of 0.382 divided by natural log of 3. And I get negative 0.875, or let's say 876 is x. So there are my 2 answers. Okay, now I'm just going to do this. I haven't done this on any of these. I'm going to check these answers. Okay, so I'm going to remind you, this is the original equation. So what I'm going to do is on my calculator, I'm going to do 9. I'm going to raise it. I'm going to check this answer right here. I'm going to raise it to the negative 0.876 minus 3 raised to the negative 0.876 plus 1. And then I'm going to add 1, and I'm going to ask myself, is that equal to 0 or not? All right, so first things first, on my calculator, 9 raised to the negative 0.876. This turned out to be 0.1459 minus, okay, when I add that together, negative 0.876 plus 1, add that together, I get 0.124. So I'm going to take my 3 and raise it to that, 3 raised to the 0.124. So this is going to be minus 1.1459, 1.1459, and then plus 1. And check it out, it works, because when you put those together, you get negative 1, then plus 1, and yes, that should be 0. Now, when you check these, you might be off a little bit, like there might be a tiny little decimal. This side could turn out to be like 0.000004 or something like that. And that would be because we had some rounding error. But yeah, I feel good about that. So we could check the other answer. Let's not do it. All right, that was 66. Let's look at 68. 68 is a lot like 66. Okay. All right, so for this one, yeah, see, I'm running into the same issue here. I'm thinking I want this to be my U, okay? And then also, I'll move the 9 over as a plus 9 and make it equal 0. But I've got to rewrite that 36 to the x as a 6 to the x somehow. So 36 is 6 squared, that's 36 to the x, but I can rewrite that as 6 to the x squared. That's same principle as last time. This becomes 2x, which is the same as x times 2, so I can flip it back. So those basically can interchange places. And so this becomes 6 to the x squared minus 6 times 6 to the x. Again, you cannot multiply those together. Order of operations, can't keep those apart. And then plus 9 equals 0. Make my substitution. U is 6 to the x. So this becomes u squared minus 6u plus 9 equals 0. Please factor. Yes. Okay, factors. U. Oh, wait, hold on. No, that doesn't factor. Dang it. Oh, well. Quadratic formula. U equals, all right, negative b plus or minus the square root of b squared minus 4 times a times c. Wait a minute. 3. Oh, hold on. Yeah, it does factor. Hold on. This is u minus 3 minus 3. U minus 3, u minus 3. Yeah, that's right. I don't know why I did that. Okay, u minus 3 equals 0. Only have to figure that out. That's u is 3. I knew I had a problem because this was about to be a 9, and then these two were going to go away, and I was going to get a 0 here. Anytime you get a 0 under this, that means that should factor. So yeah, we have it here. U is 3. Switch u back to this. So 6 to the x must be 3. And then do your log base 6, 3x, and then natural log 3 over natural log 6 using change of base formula. We're there. Natural log 3 divided by natural log 6. It's so weird because I can't ask y'all if y'all have any questions, but maybe we'll talk about it next week if you do. Okay, that's our answer there. That was 68. Look at 70 looks ugly. It looks ugly, it's not that bad. The thing is that it's hiding from you here. You've got another quadratic here, you've got it hidden here, 7 to the x. I can rewrite the 49 as a 7 squared to the x, but that's the same as 7 to the x squared. So this becomes 2 times 7 to the x squared. Remember, you can't put the 2 and 7 there together. Plus 11 times 7 to the x plus 5 equals 0. Make your substitution. U is 7 to the x. And this becomes 2u squared plus 11u plus 5 equals 0. And this, again, is going to factor. We should get 2u and u plus 1 and plus 5 here equals 0. Double check it. 2u squared plus 10u plus u, that's 11u, and then plus 5. That all works. Solve for u. U is -0.5. U is -5. Ooh, I'm not going to have a solution at all, because look, when I replace u, I get a negative number there, and that's not possible. This isn't possible. We can't ever have an exponential equal a negative number. We can confirm it by going ahead and doing the log. We'd have a -1/2 there equals x, and then here it'd be log base 7 -5 equals x. And again, you can't have a negative in a log. So there's no solution to this equation. No solution, none. There's none at all. There's no x's I can plug in that will ever make this true. All right, we are, I believe, to the last one. Okay. Yeah. All right, interesting one. Take a quick break. Okay, let's wrap this up. All right, this one is a little tricky, only because you got a negative exponent here for the first time, and here you have a positive exponent. So you can't really turn this into this by just looking at it as being like something squared. So what we're going to do, all right, is this. We're going to write it like this. We're going to take this 3 to the negative x and drop it down as a 3 to the positive x. All I'm doing is using a good old property of exponents. Yet x in -2, it's the same as 1 over x squared, right? That's a property of exponents. So I'm doing that 3 to the negative x really equals 1 over 3 to the x, and I'm dropping it down, and then the 14 just slides on top of it. So I have that, and then I have equals 5. Okay, now critical step. I'm going to multiply both sides of the equation by 3 to the x. All right, when I do that and I distribute here to here, I have 3 to the x times itself. So that's 3 to the x squared. When I multiply here to here, I get a 3 to the x on top times 14, and it cancels with the 3 to the x on the bottom, which leaves me with just minus 14. And then equals, on the other side, I multiply those two together, but I can't multiply them because order of operations, I have to leave the 5 and 3 separated. I cannot make that a 15. So now I've got this. Well, the good news is if I move everything to one side of the equation, I'm going to move this to the left, which makes it negative 5 times 3 to the x. I'm going to put that in the middle and then put the minus 14 after it. Now this looks like a problem from the previous few problems. I can make a substitution. U is 3 to the x, and this becomes u squared minus 5u, because 3 to the x is u, and then minus 14 equals 0. And I've got a nice quadratic that hopefully factors. It does, minus 7 plus 2. And we get two solutions. U is 7, u is negative 2. Replace u with 3 to the x, so 3 to the x is 7. And here 3 to the x is negative 2. All right, on this, we'll convert it to a log. Log base 3, 7 equals x, and then convert this to a log base 3 of negative 2 equals x. Can't have this, no solution here, can't have a negative in a log. This one, get on the calculator, natural log 7 over natural log 3 is x. This should be my only solution. Natural log 7 divided by natural log 3. And I get x is about 1.7712 equals x. Okay, that should do it. I think that's all the problems out of this section. Make sure it's all the evens at least. Okay, so that's it. I appreciate again you understanding about Wednesday's class. Please now take the time to work through. Let's do this. I won't make you do them all because that's a lot of problems. I want you to turn in to me, let's see, 45, let's see, 47 is just like 45, so 49 has a decimal in it. I do like this one because it has a fraction, so let's do that. 57, ooh, I like this one because it has weird numbers that might mess you up. This one, because it's the basic idea of this whole, like turning it into a quadratic. This one, because it's got a couple of things going on in there. And then let's do definitely 71. And let's say, yeah, it wouldn't hurt you to do this one. So those problems right there, let's say that you'll turn those in on Monday when we return to class, which would be the 15th. So on 11/15/21, I'd like for you to turn those in. So if you're going to come face-to-face in class, turn them in, pencil and paper. If not, I'll send a link for you to submit the problems to me. All right, you'll have a good one. Talk to you soon.